Hello everyone, and I welcome you back to our next recording. Today we're going to talk about one of the most fundamental principles of any programming language. We're going to talk about variables. Since this recording is going to be mostly theory, what we're going to do, we're not going to open Eclipse, but we're going to open up a Sublime text because of its simplicity and ease of use. So our topic today is variables. Now, if you've done programming before, you understand the concept of variables. If you have not done, if this is your first time seeing a word variable, basically what a variable is, it is a container. So what do I mean by a container? Let's say you want to store number 5 and number 7 for future use. Now, do you always have to remember number 5 and number 7, or can you give a name to number 5 and a name to number 7 and have these names define these numbers so that when you do operations on these name types, you can say, for example, number 1 plus number 2, and let the Java code define that you meant 5 plus 7, and the output is going to be 12. So this is a basic definition, basic explanation of what a variable is. It is a container that we can name and reuse down the road without having to remember all the numbers, characters, or other types of variables we might need. Okay. Now, Java variables are also known as data types. This is a technical word for a variable, and it's a data type. Now, in Java, there are two main data types. The first one are primitives. The second one is non-primitives. Let's look at primitives first. Primitives are the foundations of Java programming. Everything in Java is built on primitives and operations with these primitives. If you remember, I said everything in programming is 0 or 1. Java takes it to the next level by defining it as primitives. And then instead of dealing with zeros and ones, we're going to be dealing with primitives. Also, the second types of data, non-primitives, are everything else. Every other type of data or variable or container. Okay, so Java is going to have its primitives, which we're going to look into right now, and everything else is going to be a non-primitive. At this stage, we're not going to focus on non-primitives, their purposes and their origins. We're going to look into primitives. For some more information on non-primitives and detailed information on primitives, you can also look into our contents, reading materials, and refresh your minds. Okay, now let's look at primitives in Java. What we're going to do, we're going to look into 8 primitives that Java has and we're going to try to group them as we look into them. Let's look at first category of primitives, numeric primitives. What I mean by numeric is 0 is a number, 5 is a number, -15 is a number, and 2019 is a number, etc. Right? So we're going to deal with regular numbers. We're not going to deal with decimal points at this stage. Okay. Now there are 3 types of numeric the 3 types of numeric primitives in Java. Byte, short. I'm sorry. 4 types. Okay. Now we're going to start from the smallest by size. Smallest by size is a byte. Size is 1 byte, which is 8 bits. Minimum value is -128. Maximum is +127. Now, before we proceed any further here, let's actually take a step back and look at certain computer science principles. What do you understand by a byte and bit? Remember, every time I repeat myself saying that in for a computer, everything is either a 0 or a 1. What do I mean by 0 or 1? Computers are built to process transmitters. These transmitters are very tiny pieces, atomic pieces, that transmit electricity through them. Every time they transmit electricity, either they accept the electricity and a transmitter is on, which is 1, or it does not transmit the electricity and the transmitter is off, which means 0 from our perspective. Okay, so everything we code gives the computer commands the computer, gives the computer a command to turn a certain transmitter on or certain transmitter off. Okay, so by default, transmitters are off. That's why I'm going to put this first. So either the piece of code is going to turn the is going to leave the transmitter as is, which is going to give it a value of 0, or turn it on, which is going to make it 1. Okay, so 1 bit is equal to 1 transmitter. A transmitter can be on or off, and 1 bit can have either one of these two values, 0 or 1. Okay, now what do I understand by 1 byte? 1 byte is equal to 8 bits. Okay, every time you say 1 byte, you think of 1, 2, 3, 4, 5, 6, 7, 8 bits. These bits can either be 0 or 1. 0. Let's say this one is going to be 0. This one is going to be 1. This one is going to be 0. This one is going to be 1. For example, 0. Now, if in 1 bit I have a possible 2 values, how many values am I going to have? How many possible values am I going to have in 8 bits? So 1 bit has 2 possible values. 8 bits have 2 to the power of 8 possible values, because this can be 0 and 1. While this can be 0 and 1, this can also be 0 or 1. So there are 4 chances of there are 4 possibilities if there are 2 bits, right? So this can be 0 or 1. While this is 0, these can have 4 possible values. While it is 1, these can have the same 4 possible values. So obviously there are 2 possible values here that can make this 4. Obviously, if we had a 3-bit memory, we could have 2 times 4, 8 possible values. So you see where this is going, right? Every time you add 1 more bit to a memory, dedicate 1 more bit to a memory, what happens is the number of possibilities is increased, is multiplied by 2. So if I had, let's say 2, so this is basically 1 byte, right? 1 byte is equal to 8 bits. Now, 16 bits have 2 to the power of 16 possible values. This is 2 bytes. Basically, I'm not going to go any further. We're going to look into this again, but you get the idea, right? So if I had 8 more bits dedicated to it, let's say 1, 2, 3, 4, 5, 6, 7, 8. This is going to be a total of 16 bits. There are 2 to the power of 16 possible values to this slot in a memory. Okay, now let's go back to where we left off. So back to numeric primitives. The smallest numeric primitive is byte, and obviously its minimum value is negative 128, maximum value is positive 127, the plus value of 0. Its default value Default is 0. Okay. Now, first thing first, now we understand what 1 byte and 8 bits mean. Second, why do we have a minimum of -128 and maximum of 127? Reasoning is, as we explained earlier, behind the number of possibilities that 1 byte can have. 1 byte can have 2 to the power of 8 possible values. Total possible, so the volume, I'm trying to find the best word to call this. So let's do this. Total possible values is equal to 256. So we can open a calculator and we can say, it's not too big. We can say 2 to the power of, oh, it's square root of 2. Okay. Now 2 to the power of 8. I'm not going to be able to do it. So let's do this. 2, okay, let's delete this. 2 times equal to. This is power of 2, 3, 4, 5, 6, 7, 8. We have 256 possible values in 1 byte. And out of those 256 possible values, 128 of them are dedicated to be negative numbers, 0 and additional 127 of them are dedicated to be a possible value. Basically, a byte is a container with a size that can contain with the size of 256 possible values, and these values can be between -128 to +127. Okay, let's move forward. Second type of numeric primitive is short. As it is defined by its name, it's not going to be too big, it's going to be short. So, but it's actually 2 times bigger than a byte, right? It's 2 bytes and 16 bits. However, 2 times bigger does not multiply this by 2, but total number of possible values is not 1 byte by 2, but there is a factorial increase to it. It is 2 to the power of 16, right? You remember here we have now 2 to the power of 16 bit, but 2 to the power of 16 possible values. The same here. Short is going to have 2 to the power of 16 possible values, and that's going to be, so we're here at 8, 9, 10, 11, 12, 13, 14, 15, 16. 65,536. 65,536. Okay, minimum is negative, I believe 32,000 and something. Let me find out the precise values just for the instruction purposes. Now, you do not have to remember these numbers. And there's no way you can remember these numbers. I mean, you can definitely, but most important thing is, if asked what is the maximum or what is the minimum value, if you give an answer from this point of view that the size of a short is 2 bytes, right, or 16 bits, this means it can have as many values as 2 to the power of 16, then and that's going to be equal to something. You can calculate it to be equal to 65,000. Then out of these 65,000, 32,768 is dedicated to be negative values, and maximum is obviously 32,767 because 0 is calculated within these values. Default value is 0. Okay, now what you need to remember from these: name of a primitive type, name of a data type, size of it as in bytes and bits. If you remember just byte, you will know that if 1 byte is 8 bits, 2 bytes are 16 bits, right? And that's it. Maybe also default value, but these are pretty standard. Okay, let's move on to the next numeric primitive. It's called int, short for integer. Okay, but I will just delete this not so as not to confuse you. We're going to call this an int from now on. If you hear int, this is what we mean. Size is 4 bytes, or 4 times 8, 32 bits. Right? Now, total possible values. This is going to be a little bit, a lot more. So, getting back to our calculator, right now we have increased 2 to the power of 16. What about 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 30, 1, 2. Total possible values of 4 billion. Copy, paste, remove these because Java does not use commas. I'm going to tell you what you can use to make it readable, but down the road, not now. Minimum is basically this divided by 2, negative 2,147,483,648, and maximum is 2,147,483,647, right? Plus 0. So let's minimum, right? And default value is 0. There are a few things that you need to remember about int. This is, I'm going to put a star here, and I'm going to explain. Int is the default numeric variable in Java. Anytime you use a number anywhere, if you do not specifically declare it is of any type, it's going to be of type int. Now, if we have int and if we can use so many numbers within, why do we need short and byte? Where are these coming from? Do you remember that Java was initially developed from the point of view that code developed in Java can be run anywhere, including coffee machines, toasters, vehicles, and all kinds of systems, right? So certain systems do not have the memory capabilities. To save memory, Java has introduced these small numeric primitives like byte and short. Int, again, is a default, and most of the time we're going to be using int, but you need to know what byte and short stand for. Okay. Now, last but not least, we have long. Okay, so long size of a long variable in memory of a machine is 8 bytes or 64 bits. I'm not going to calculate total possible values. This is going to be, I'm just going to leave it here. You do this calculation. This goes to trillions or quadrillions. I don't know how you call that, right? So obviously, I'm not going to show you what the minimum or maximum number is. The default value for long is 0. Now, you can think about the possible usages of long. If int is a default, it has up to 2 billion negative numbers. It can contain up to a number that is as low as negative 2 billion, or contain a number that is as high as positive 2 billion. Well, long was necessary because, for example, the population of planet Earth is 6 billion. Oh, I'm sorry, recently 7.5 billion or so, right? You cannot store that number as an int. Or you have for bank operations where you're dealing with large numbers. That's where the long is going to come. There is one thing you need to remember about long. Anytime you define a long, you have to write a letter L. The lowercase letter L is also acceptable. However, just to avoid confusion of this with number 1, always type in uppercase letter L. So anytime you want to specifically use long variable, you have to add L to the end of a number. So this is a long number. But if you do this, Java is going to try to think that this is an int, and it's going to fail. Compiler is not going to run the program. That's why if you want to do this, then please add L at the end of your number. These are all your numeric variables. I'm going to pause this video at this stage before it gets too long. So what we looked at until now is what variables are, and we define them to be simple containers with given sizes, right? And variables in a global declaration are part of data types, are also known as data types. Java gives us two data types, primitives and non-primitives. Primitives are the foundations of Java programming, right? And there are eight types of primitives. We're going to look into them in groups. Non-primitives are everything else, every other data types in Java. We'll look at them at the later stages. And only thing we need to remember is non-primitives are built on primitives. Okay. And we looked at the concept of computing. The concepts of possible number of values in a memory allocation. We looked at 1 bit being 1 transmitter, 8 bits, 1 byte being 8 transmitters dedicated. So if 1 bit has 2 possible values, 8 bits have 2 to the power of 8 possible values. And we looked at the implications of these memory allocations when we looked at the numeric primitives in Java. There are 4 of them, byte being the smallest one with a size allocation of 1 byte, short being second smallest, size allocation of 2 bytes, int being the default Java primitive on numerics. It has a size of 4 bytes, and then if you want to store really big numbers, you're going to need to use long, and when you write a long number, you need to add L to the end. Okay, thank you very much for your time. We'll get back. I'll be with you shortly. I'll be with you during the next video with the other types of primitives.